Alright, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And today we are going into Windows Forensics 2, which is a part of the Digital Forensics and Incident Response module of the SOC Level 1 pathway inside of TryHackMe. And as you can see, there are a lot of modules that are available, a lot of rooms that are available inside of the Digital Forensics and Incident Response room, and I'm honestly very excited about all of them. So today we're going to jump into Windows Forensics 2. If you would like to learn more about forensics or security analysis, penetration testing, ethical hacking, all that good stuff, please like, subscribe, and turn on that notification bell, and maybe even drop a comment. When you do any of those things, or maybe all of those things, two things happen. Number one, you actually help our channel get a little bit more reach with the YouTube algorithm so that we can actually help more people just like you who are trying to study for cybersecurity and penetration testing, so on and so forth. But the more important thing is that when you turn on that notification bell, you actually get notified the next time a video comes out, which means that if you're studying for CySec or pen testing, all of these things are actually applicable to you, and you will learn more for your examinations, and you'll also learn more for your actual job. So if you want to go into digital forensics or become a cybersecurity analyst, all of these things are directly applicable to you. And I've used a lot of these skills that I've learned from TryHackMe on resumes and in job interviews, and they've helped me tremendously. So it's a win-win situation in my humble opinion, but you're more than welcome to just watch and kind of tag along and check on the channel whenever you get a chance. But I think it would be amazing if you could actually join our community and subscribe and turn on notification and so on and so forth. So without further ado, let us jump into the introduction of this room. All right, so we talked about Windows Forensics in the previous video that we did. This is actually the second room for Windows Forensics. So we're gonna go a little bit deeper into the forensics. The last video was around the registry, where we found a lot of stuff within the Windows registry, which a lot of things do exist when you're trying to do evidence gathering and artifact gathering, so on and so forth. So in the rest of this particular room, what we're going to do is go into the rest of these tools. The NTFS file system, the FAT file system, recovering deleted files, so on and so forth. So it's going to be a good, robust room. And let's actually get into the FAT file system. The FAT file system is the file allocation table. One of these is one of these big systems that are specific to people. They're specific to information being gathered in specific parts of a computer. So a hard disk or a USB is just a collection of bits. And to convert these bits into meaningful information, they have to be organized. And for that, engineers and computer scientists have created something or various types of file systems. And one of them is called the file allocation table system. And it's been the default file system since the late 70s, and it's still in use. It's not the default anymore, but it's still in use. It's been grandfathered, as they say. And the file allocation table, as the name implies, it creates a table that just indexes the location of the bits that are allocated to different files. So information is just bits inside of packets, inside of data, yada yada yada. So everything is just bits, ones and zeros, as they say. And there's different versions of systems that manage these bits. The data structure of a FAT file system, I really like saying that, FAT file system. The data structure of the FAT file system works like this. It can work in clusters. It's a basic storage unit of the FAT file system. It's so fun to say. The FAT file system, each file stored on a storage device can be considered a group of clusters containing bits of information. And then you have the directory, which you should already know, which basically has a bunch of files in it or other directories in it. And it can have the file name, the starting cluster, file name length, etc. You have the file allocation table, which is what FAT stands for. And it's a linked list of all of the clusters. It contains the status of the cluster and the pointer to the next cluster in the chain. So in summary, the bits that make up a file are stored in clusters. All the file names on a file system. They're stored in clusters, and their links are stored in directories. And the location of each cluster on the disk is stored in the file allocation table. We can see that we started with a raw disk composed of bits and organized it to define what group of bits refer to what the file stored on the disk. So yeah, FAT12, FAT16, and the fattest one, FAT32. The FAT file format, look at that, that's fun to say, divides the available disk space into clusters for some straightforward addressing. The number of these clusters depends on the number of bits used, hence the different variation of the file system. FAT was initially developed with 8-bit cluster, and then it grew and it became 12 and then 16 and now 32. So the last one of them was introduced in 96, and theoretically FAT12 used a 12-bit cluster addressing for a maximum of 4,096 clusters, so 2 to the power of 12. FAT16, 16-bit cluster for 65,536 clusters, 2 to the power of 16. So that's basically what it means. So I'm guessing that this one is going to be 2 to the power of, oh, it's not 32. Okay, so I thought it would be 2 to the power of 32, but it says the actual bits used to address clusters are 28. So the maximum number of clusters is 268 million, or 2 to the power of 28. That's crazy. So however, not all of these clusters are used for file storage. Some of them are used for administrative purposes to store the end of chain of clusters and unusable parts of a disk and so on and so forth. So this is kind of what it looks like in a table format. You have the attribute itself and the name of the file system, addressable bits, max number of clusters, supported size of clusters, and max volume size. And I mean, as you can tell, it just gets bigger and bigger and bigger. So it's kind of a simple way to understand these things. Even though the maximum volume size for FAT32 is 2 terabytes, Windows limits formatting to only 32 gigabytes. However, volume size is formatted on other OS with larger volume sizes are supported by Windows. The chances of coming across a FAT12 file system are very rare nowadays. FAT16 and 32 are still used in some places like USB drives, SD cards, or digital cameras. However, the maximum volume size and the maximum file size, which is 4 gigabytes for one file size for both 16 and 32, are limiting factors that have reduced their usage. And then you have the exFAT file system. As the file sizes have grown, especially with higher resolution images and videos being supported by the newer digital cameras, the maximum file size limit of FAT32 became a substantial limiting factor for camera manufacturers. Though Microsoft had moved to the NTFS file system, it was not suitable for digital media devices as they did not need the added security features and the overhead that came with it. Therefore, these manufacturers lobbied Microsoft to create exFAT, and it's now the default for SD cards larger than 32 gigabytes, which I mean, I literally have SD cards that go into like 256 gigabytes, 512 gigabytes. You can even get SD cards that have terabytes on them. And we're talking about SD cards. We're not talking about USB drives or anything, like those little slim types of things that get plugged into the little SD card, because you have the micro SD card and you have the regular SD card. And so micro SD cards can also come with like 128. It's pretty crazy. So the exFAT file system supports a cluster size of 4 kilobytes to 32 megabytes. It has a maximum file size and a maximum volume size of 128 petabytes. Whew. It also reduces some of the overheads of the FAT file system to make it lighter and more efficient. It can have a maximum of 2.7 million files per directory. That is crazy, dude. Anyways, how many addressable bits are there in the FAT32 file system? And this one was actually 28 is what it maxed out at. What is the maximum file size supported by FAT32? And that was 4 gigabytes, I want to say, right? That's what the maximum size was. Yeah, there we go. Which file system is used by digital cameras and SD cards? And it's exFAT. Oh, whoops, I misspelled that. exFAT. And just like that, we got the first portion of this, the FAT file system. That's just fun to say, man. All right, moving on to the next one, the NTFS file system. The NTFS file system. So as the FAT file system is a very basic system, it does the job. But then there was something that was developed to kind of handle more capabilities, right? Have more limitations, higher limitations. And that is New Technology File System, the NTFS. And this was introduced in 93 with Windows NT 3.1. However, it became mainstream since XP. And the NTFS file system resolved many issues present in FAT and introduces a lot of new features. So for example, we got journaling, keeps a log of changes to the metadata in the volume. This helps the system recover from a crash or data. So now this is where you kind of can see where this connects to digital forensics. So I want you to now keep in mind everything that we talk about from here on, and everything previously as well. It's good to know about FAT and XFAT and all those things, but now you can really pay attention to how all of these new concepts apply to digital forensics and incident response. So journaling keeps a log of changes to the metadata in the volume. This feature helps the system recover from a crash or data movement due to defragmentation. This log is stored in the log file variable in the volume's root directory. Hence, the NTFS file system is called a journaling file system. There are access controls. The FAT file system did not have access controls. NTFS file system has access controls that define the owner of a file or directory and the permissions for each user. You have the volume shadow copy. The NTFS keeps track of changes made to a file using a feature called volume shadow copies. Using this, a user can restore previous file versions for recovery or system restore. In recent ransomware attacks, ransomware actors have been noted to delete the shadow copies on a victim's file to prevent them from recovering their data. See? Alternate data streams. A file is a stream of data organized in a file system. Alternate data streams is a feature that allows files to have multiple streams of data stored in a single file. We actually did this in one of the previous videos, but we didn't do a deep dive on it, so I'm interested to see how this ends up playing out. And Internet Explorer and other browsers use alternate data streams to identify files downloaded from the internet using the ADS zone identifier. Malware has also been observed to hide their code in ADS because it's not the immediate visible data. It's actually an alternate data stream that you would have to run certain commands to see what's hidden inside this file or what the alternate data stream actually is. And so since it's not immediately visible, we can actually hide stuff in it as attackers, you know what I mean? But if you're a forensic analyst or if you're a cybersecurity person, you need to keep that in mind. Master file table, like the file allocation table, there's a master file table in NTFS. However, the master file table, or MFT, is much more extensive than the FAT, and it is a structured database that tracks the objects stored in a volume. Therefore, we can say that the NTFS file system data is organized in the master file table. From a forensic point of view, the following are some of the critical files in MFT. So we have the MFT, the first record in the volume. The volume boot record points to the cluster where it's located. MFT stores information about the clusters where all other objects present on the volume are located. This file contains a directory of all the files present on the volume. And then you have the log file that stores the transactional logging of the file system. It helps maintain the integrity of the file system. Then you have the USN journal, which stands for the update sequence number journal. It represents the extend record and contains information about all the files that were changed in the system and the reason for the change. It's also called the change journal. Okay, and then the MFT Explorer, it's Eric Zimmerman's tool. I actually requested this guy on LinkedIn because I think he's a badass. And literally every single person that's been shown inside of TryHackMe as a developer, I've gone on LinkedIn and requested to connect with them, and they've all accepted to connect with me. And I just tell in like a message as I send the connection, I'm like, hey, listen, I just use some of your tools. They're amazing. I would love to have you in my pool of connections because yada, yada, yada. So I recommend finding these people on LinkedIn and going and connecting with them because these are the developers of the tools that you're going to be using. And when you tell them that you use their tools, these are people that you want to know you and connect with you. And then you can post about the tool that you just used, and maybe even in the future you can partner up with them, business partner up with them. And anyways, so MFT Explorer is available in command line and GUI versions. We'll be using the command line version. Start the machine attached, which I already did. It'll open split view, and then you can do RDP if you wanted to. And so what we're going to do is run these commands to navigate to the directory and run the command and do all the good things over here that can be done. So we're going to run those commands and find the answers to these questions. So let us open up that machine, and I'm going to open up in a full screen view so that it's a little bit nicer for the recording. And then from here, I'm going to have this specific room available in a different browser so that we can kind of look at it, or I can record and have this in a different browser, so that way it'll just be easy for me to find these commands and type them up and so on and so forth. So here we go. This is the channel, by the way. We're growing, so thank you guys so much for your support and your contribution to the community. I love you guys tremendously. I love you. If no one else loves you, Hank loves you. Let me just tell you. All right. Okay, so the first thing that we want to do is we want to open up a command prompt as an admin. So you go down here. Okay, here we go. So you go in the search box, you type in command or cmd.exe, and then you right click on the thing, and then it gives you the option to run as administrator. All right, so here we go. Now we are here and we are zoomed in on our command prompt here. And the first thing that we want to do is load up the executable, which is inside the Easy Tools directory on the desktop. So I've got to go to cd c users, and then let's see what we got here. We got THM 4 and 6. That's the one that I got to go to. So THM 4 and 6 is what we're going to go to. And then we're going to clear the screen real quick. And then I got to go into the desktop, and I got to go into Easy Tools. And there we go. Or whoops, dir. And here's everything. And we're looking for mftecmd.exe, which is right in the middle of the screen right here. So great. So that's what we're going to just run. So anytime that you want to run a executable, you basically just type it, including the exe at the end, and then it'll run. And let's see how long it takes for it to load up. All right, so this is basically all of the options that are available inside of MFT, and this is what the command essentially looks like. You would run the executable and then F to choose a file that you want to scan, and then you would output it into your preferred output format. And then you need to dedicate what the location of the output is going to be, and then I guess you can also even name it as the output file. And that's basically it. If you do just this, I guess it doesn't specifically name it for you, and it'll choose its own name format. And then you can do JSON format, the body. Let's see what the body stands for right here. Body is a directory to save body file, formatted results to. It's also required when using this option. Okay, fair enough. And then you have the DE format, which is dump full details for entry sequence number. Format is entry or entry sequence, so on and so forth. So that's basically it. So you just run the command itself, the file that you want to scan, and then your output that you want to do. So with that in mind, we are now going to parse the files that are present in the desktop on the desktop that we're on, but there's a file called triage and C. So it's inside that place. So what we're going to do is we're going to run it basically and analyze it, and it says what's the size of the file that's located inside the Windows such and such directory. So we are going to go ahead and first run the command. Okay, so pretty basic command. And I'm gonna just kind of shrink this a little bit so we can actually see everything. And so, yeah, just ran the command. The file that we're supposed to be analyzing, the CSV, is going to be inside the desktop and in an output folder. So hopefully it'll just create the output folder for me and it won't give me an error message. And this is the name that I want it to be. So let's run that and hopefully it'll actually run. Okay, it finished and it actually took a very, very short amount of time. Like it says right here, 37 seconds. But I had to press enter, I don't know, 3 or 4 times before it finished. And uh, before I pressed enter, like the second or the third time, I had waited a good 10 minutes maybe. And nothing was happening on the screen. And I was like, okay, maybe it didn't register. So I pressed enter a few more times and then it started. And then this thing came up and then this part came up and then this came up and then this came up. So it took altogether about 37 seconds or so. But it was after I had pressed enter a few times. I don't know exactly what was going on or whatever, but if that's happening to you, you need to press enter a couple of times for it to actually register, and then this thing comes up right away. This part comes up immediately after it's actually registered the command. So that's neither here nor there. And since it's now done, we can look at this file right here, and I understand why they created or they would designate what the output file name would be, because this is what it looks like. So 2024 210 at whatever time, and then that's the command, so on and so forth. So now question number 1 is, what is the size of the file that is located at this particular directory? And then the next one is, what is the size of the cluster for the volume from which the triage was taken? And it's saying that the next one is for parsing the boot file, and then to use Easy Viewer. This one was to parse the original MFT file. Oh, that was actually the other thing. That was the other piece of the information, is that the first few times that I ran this, I did not include MFT at the end of what I was doing. I was just running C without the $ MFT. And every time that I did that, it would give me a parse error saying that nothing, it didn't say that what was missing or whatever. It just said that it can't parse this. And I tried doing that several times, and I tried going through a bunch of different troubleshooting before I realized that I was actually missing the file itself. So the first part is, when you do this, make sure that you include the $ MFT at the end of your path, and then make sure you press enter a few times so that you can actually get your result. So from here, we are now going to, I'm going to try to open this and see if it'll open just by itself. We can do more apps and then see if we can look for another app on this PC, and then go to Easy Tools, and then what's the name of the tool that they told us to use? You can use Easy Viewer for Easy Tools. So there needs to be something called Easy Viewer inside of Easy Tools, and it's right here. And we're going to use Easy Viewer to open it. All right, here we go. And now we need to get the file that is under Windows Security Logs, SCE Setup Log. So I need to go to Windows, SCE, I think this is it right here. So if I kind of expand on this, that would be, yeah, that's the Windows Security Logs, and then the SCE Setup Log, which is this thing. And so that is the file size that we're looking for. And from here, we're now going to go and just drop this right here. And there we go. We got the answer. Now it says, what is the size of the cluster for the volume from which this triage was taken? And that needs to be parse the boot file. And let's go find the boot file, and then from there, parse it. So we're going to exit. And that's going to be inside triage on the desktop. And let's go find that. All right, there you go. So boot, just like that. And so I'm going to basically use the same exact command, except at the very end of this, I'm just going to change it to boot, like that. Should be lowercase, I believe. Yeah, so boot. And then we're going to have it be in the same exact output file. and I'm going to press enter a couple of times to make sure that it is actually running, and hopefully from there it'll start it'll start fairly quickly. All right, there we go. That was a little bit quicker, and it's mainly because I kept clicking enter. And so when I would click enter, it seemed like it would unselect this window, and then I would have to click on it and again and press enter again. As you can see, I did 4 extra times or 5 extra times after the initial enter that I pressed. And so now we got it, and here it actually shows us the output, I think. So this might be something that we might be able to use. What's the question here? What's the size of the cluster for the volume for which this was taken? So the cluster MFT cluster block number is that. Cluster size is 4096. So we're going to do 4096, and that is our answer. Very good. Okay. Once I figured out that you had to press enter a couple of times to just make sure that it actually runs, that was not all too bad. Okay, so now moving on to recovering deleted files. Deleted files and data recovery. So understanding the file systems makes it easier to know how files are deleted, recovered, and wiped. As we learned in the last 2 tasks, a file system stores the storage of a file on a disk, the location of a file on the disk in a table or a database. And then when we delete a file from the file system deletes the entries that store the file's location on the disk. For the file system, the location where the file existed is now available for writing, or it's unallocated. However, the file contents on disk are still there, as long as they are not overwritten by the file system while copying another file, or by the disk firmware while performing maintenance on the disk. So it may be deleted and the place is available, the location where the file existed is now available for writing, or it's unallocated, but the contents on the disk are still there. Similarly, there is data on the disk in different unallocated clusters which can possibly be recovered. To recover this data, we have to understand the file structure, and we can see it in a hex editor. However, we will not cover that in this room. We're going to use a tool that does this work for us and identifies deleted files in a disk image. What is a disk image file? A disk image file is a file that contains a bit-by-bit copy of a disk drive. A bit-by-bit copy saves all the data in a disk image file, including the metadata in a single file. Thus, while performing forensics, we can make several copies of the physical evidence, an example, the disk, and use them for investigation. This helps in 2 ways. The original evidence is not contaminated, and the disk image file can be copied to another disk and analyzed without using specialized hardware. Recovering files using autopsy. So we talked about this in the intro to this module. So we have autopsy. We're going to double click it to run it. Click on new case, and it's going to look like this, and then enter a name to save the case. And that's basically it. It didn't even really do much after that. And then you can do the optional information, required details. We're just going to click finish to move forward, and then we're going to select a host. And from here, let's see what the instructions for this is. Since we'll be performing analysis on a disk image, select the topmost option, which is disk image or VM file. I see. So this instruction is right here. So we're going to click finish, move forward. It's going to do some processing and then show the following screen, which is this. We're going to click next. And then from here, we're going to do disk image or VM file. And then it's going to ask for the data source, which is going to be what we're going to probably use in this thing. And then provide the location of it. And you'll find a disk image named USB001 on the desktop. Provide the path to that in the above window and click next. You will see the following window, which is this. And here click deselect all. These are different modules that autopsy runs for processing. For this task, we don't need any of these if enabled. They take a lot of time to run. Click next after deselect all. Autopsy will load the disk image, and you'll see the following in the left panel. And the data sources show the data sources that we have added. We can add more sources. File views and tags menus, what autopsy has found. The expand the data sources, click on the USB001 device autopsy will show the contents of the disk image in the following way. And then the contents are shown on the right side, so on and so forth. Notice the X mark on the last file in the screenshot named New Microsoft Excel Worksheet. This indicates that this is a deleted file. Deleted files will have this X mark on them. So it's going to be, when we click on USB, it's going to be this thing at the very, very bottom that has the X mark next to it. And then we can extract deleted files by right-clicking on it and then provide the path to save the extracted file, and we will have the deleted file recovered. So let's see what else we can find. So there's another XLSX file that was deleted. What is the name of that file? And so I'm just going to go inside here now, and I'm just going to minimize this just in case we need the command line later. And from here, we're going to open up autopsy. I'm going to select the base directory to be the exact base directory that they used, and that's going to be fine. And then case name is going to be, what is it, USB, I think is what it was called, USB 001. And then next on that. And from here, we don't need to do much as they said. We'll just leave that. And then now it's going to create the database. And then we'll get an option to deselect everything. Okay, so it loaded this for us. We're going to click on next. And then disk image. The original selection was local disk. I changed it to disk image. Click next again. And now we want to browse for the file, which is on the desktop, and it's called the USB 001. And now click next. And then we're going to deselect all of this stuff. Click next. And it should now take a little while for this to load onto our screen. And finish. And there we go, just like that. I think it's all good. Now I need to expand data sources. Click on USB and open USB like so. There we go. Okay, so now we actually have the full thing. And so there is another XLSX, which is TryHackMe.xlsx. That is the answer for that. Let's get out of this and go down here. It's going to be TryHackMe.xlsx. And what is the name of the TXT file that was deleted, which is TryHackMe2.txt. So that's that. And then recover the TXT file. What was written in the TXT file? So we're going to go here, right click on the TXT file. We are going to extract the file, and it's going to ask us where you want to do it. I'm going to go to desktop, and I created a little folder for this, and I'm going to put it inside the USB and save it. File has been extracted. We're going to open up our file explorer, go to the desktop, go to autopsy, USB, and TryHackMe text file is right there. We're going to open that up, and this is what we got. So copy that, go here and paste that. And just like that, we did our first autopsy. Exciting stuff. Okay, now we are going to move to the next one, which is evidence of execution. All right, so Windows prefetch files under evidence of execution. This information is located in prefetch files, which are located in Windows prefetch directory. And so the prefetch files have an extension of PF. They contain the last run times of the application, number of times it was run, any files and devices handled used by the file. Thus it forms an excellent source of information about the last executed programs and files. We can use prefetch parser, PECMD, from the Zimmerman tools for parsing this, and then you just run that in an elevated command prompt, which I'm glad I didn't close out. And so this is what it's going to look like, and then these are going to be the options that we have for it, and the use cases are going to be like this. So you choose the file, and you can do an output format for it to give you output format in CSV as well, and you could do K. So let's see what some of these options are. So it says to run it on a file and save the results in a CSV, we could do this. To run a whole directory, we would have to do the D path, or the D option, and you can do that and save it to a CSV. And then you have the Windows 10 timeline, stores recently used applications and files in SQLite database called Windows 10 timeline. This data can be a source of information about the latest executed programs. It contains the application that was executed and focus on the time of the application. It is under the user, whatever the username is, app data, local, connected, so on and so forth. We can use the WXTCMD from Zimmerman, and we get the following options to look at it, and we can run it against the file and output to a CSV. And then we also have jump lists. They go to their recently used files from the taskbar. So we can view jump lists by right-clicking on the application in the taskbar, and it will show us recently opened files in that application. The data is stored in the following directory. Okay, yeah, I've seen that, because it's like the most recently visited links on your browser, for example, or if you used, Adobe Acrobat to open PDFs, it'll show you the most recent files that you open inside of that. So that is stored here. And then there is JLECMD by Zimmerman that will be run, and it can extract like so. So you choose the file, the output, and in triage, we have extracted the Windows directory of a system we want to investigate. It retains the directory structure of the original Windows directory, that is C Windows, and is mapped onto user THM desktop triage C Windows. Now let's see the information we have learned in the triage and so on and so forth. So how many times was such and such executed? If you're having trouble, you can use Easy Viewer, so on and so forth. Okay, so we're going to answer these questions. So let me open this up in my next window, and we're going to go to evidence of execution, and let's see what we can find here. And in Easy Tools, I think is where the first one that we need is, it's called PECMD, and PECMD is right here. So let's move this so we can kind of zoom in on a little bit. And here we go. So we're going to clear this screen, and what we need to do, let me make sure that it actually stays onto the screen. What we need to do is run PECMD against which file? So it says the gcape.exe. So how many times was that executed? And I need to actually just make sure that I have that all correctly. So here's what we're going to do to make our lives a little bit easier, because we want the path of these things. So it's going to be on the desktop, obviously, and it's going to be in triage. And so if we do a dir, we can see that there's something called C, and we'll go in there and we'll do a dir. And then is the executable that we want, it's inside Windows. And let's do a dir for this. And there is these things. So now I need to see where that is located. So based on the instructions that we got, it says we have extracted Windows, it's inside C Windows, and it's mapped onto triage C Windows. Now let's see the information. So and so how many times was the gcape.exe executed? So I need to find gcape.exe, and it seems to be, what is it, under prefetch, I guess? Would that be where it's located? Yeah, so gcape.exe is actually in prefetch, and this is the full path from it. So what we need is to copy this piece right there, and then what I need to do is do a cd command to get the full directory line right there. And so to combine this, I'm just going to leave this kind of at the bottom of the screen right here, and then click on that, and then we're going to go and zoom in on this a little bit. And to be able to pull that, we need to use, what was the name of the tool again? It was PECMD. So it's going to be PECMD.exe, and it's going to be file because we're looking at a specific file, yeah. And then the path of that file is going to be C users And then I'm going to do a paste command. Okay, that doesn't work. That's great. So what if I did right click? Okay, great. Right click by itself, just typed it. Very good. And now I want to have an output. I'll do a CSV output. And where are we going to put this? We'll put it on our, I'll just put it on the desktop. So it's going to be C users THM4N6 desktop, and that'll be it. And we're going to press enter, and then make sure we click on this again, press enter, click on it again, press enter, click again, enter, and I'll just do one more time for good measure. And hopefully this will run, relatively quickly. So let's see how long this takes to run. Okay, 6th time was the charm. As soon as I pressed enter the 6th time, it ran it, and we got all of this information that printed onto the screen. Let me see if I can get a count of anything. 40 file references, directories referenced, etc. So it doesn't give me that. Enabled name hash, file size, version, run count 2. So maybe that's our number. So it says how many times it was run. 2. Okay, very good. What is the last execution time of gcape.exe? Let's see if we can find that in here. Last accessed on this time. There's this date right here, so this might be the proper information, which is the last run. So 12/1/2021 at 13:04. Let's do that. Yeah, that was the right one. And so when notepad.exe was opened on 11/30/2021 at 10:56, how long did it remain in focus? Okay. For that question, we need to use this tool, WXTCMD, about the last executed program. It contains the application that was executed and the focus time of the application. So what we want to do is we want to run that command against the notepad.exe, which it says triage data is in the folder yada yada yada. All right, the file that we're actually looking for is not in the regular place that was in Windows as we go through this thing right here. So it tells us that typically they are these files that we're looking for are located inside of the users, username, app data, local connected devices, random folder, and activities cache database. And so this is what our path looks like. This is the full path right here. So it's on the desktop triage C, and then we got to go into users, and then the user, app data, local connected devices, and then that's the random folder. And then from there we found 3 database files. And so we have activity cache database, database SHM, and database WAL. And so I'm just going to use the one that's activities cache database, and let us see how that works. So I'm going to go back here, rerun the same exact command, except we're just going to use a different file here. Instead of the notepad.exe that was inside prefetch, we're just going to use this full long path right here, and then we're going to add application cache at the end of it, and like this, and it's going to be back app or activities, excuse me, activities cache .db, and then we're going to do that in a CSV file. And just to kind of keep things a little bit organized, I'm going to do a new thing, and it's going to be activities is going to be our output file, and hopefully that'll work well. Just press enter, and that worked well, and no error messages this time, which means we actually had the proper one. So it's actually inside the users folder. Okay, that makes more sense. So if I go back to our little thing right here and go in this PC and then go to local disk users, there should be something inside of this called activities. Yep, right there. And there it is. And so, okay, so we got the activity and then the package IDs. And so the question that I'm trying to answer here is asking for what? It's asking for how long did it remain in focus? Okay, so let's just open this up and see what we can find. All right, here's our CSV file. And what we're looking for is the executable notepad. So let's see where that is. All right, so here's notepad exe right here. And the in focus value is actually what we're also looking for. So what I'm looking for is the duration of the in focus value for notepad exe, which seems to be this specific field, which is 56 seconds, it seems. So let's see if this is actually right. Oh my gosh, that is not the file that I wanted. So copy this, and there we go. It's incorrect. What? Oh, there needs to be an extra 0 in the beginning. So 0 and then that. That's still incorrect. What? What are you talking about? So on 11/30/2021 at 10:56, how long did it remain in focus? Are there multiple instances of Notepad exe that I'm missing? Okay, so there are multiple instances. And so if we kind of, the start time, it looks like this, right? So it has all these hash signs until you expand it. Then it actually gives you the date on it. And so there are multiple instances. I was looking at this one, which is at 10:55, and it's asking for 10:56. So this is the instance of Notepad exe 10:56, which is 41 seconds this time. So we're going to still put that 0 in the beginning, but then we're going to do 41 seconds. There is the answer. And what program was used to open C users yada 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 changelog? And the hint is going to tell us to use what? JLEC CMD, and then triage that's inside this over there. And so where are these things typically located? App data, roaming, Microsoft, so on and so forth, automatic destinations. So we're going to use JLEC CMD, and then we're going to go into specifically automatic destinations, and we're going to find that answer. So let's close some of these things out, and let's go to the appropriate location. So it is still in app data, I think, right? So let's see. Jump list. Yeah, jump lists. It's still app data, but it's now roaming instead of local. So we're going to do cd, go back 1, 2, 3, and now I can go to cd roaming. And let me do a dir right here. And it's going to be roaming Microsoft Windows recent. cd Microsoft Windows. And do we have a recent in here? Recent, there we go. And let's do a dir over there. And there it is. And there it is, automatic destinations. So now I need to, because I think I closed my command prompt that was run as an administrator. So I got to open that up back up real quick. And then from here, we're going to run the new command at that specific location. I got to go back into my tools, which is located where? All of these things, gotta find my list of tools again, because I closed them. So let's see. Okay, desktop easy tools, that's not bad. And then we're gonna go and try to find this very last freaking item for changelog txt. So cd users thm, what is it, 4 something, what is it? Let's go users, do a dir, cd thm4, and take me there, and then go to the desktop, and let's clear that screen up. And it is easy tools, and there's all of our tools, and we're looking for JLEC, which is right there. And for JLEC, I need to be able to pull that specific path that's down there. Okay, so it's going to be JLEC md.exe and it's going to be file, and we're going to use this whole thing because this is a long path, so I'm definitely not going to spend the time typing that up because we got to get shit going. This is too long for me to sit here and type things like that. And then recent, and it's going to be called automatic destinations. And so a nice little trick is if we just type in auto and press tab, it fills the rest for us. And now we want to do a CSV, and I will go ahead and output this to and we'll just do desktop, fuck it. And there we go, and press enter. Let's hope this thing works. All right, so here's what we learned. There's actually multiple files inside of the automatic destinations folder, and I used the incorrect parameter here. So we're gonna run the same exact thing here, except what we're gonna do is we're gonna change one tiny, teeny weeny little letter, which is we're gonna switch from F to D to change this into a directory recursive search. And then so now it's going to search everything inside of this automatic destinations, and it's going to give us our result. So let's wait for that to happen. I'm going to press enter multiple times until it freaking does it. So let's go. Okay, so it finished processing and we got it. So now the question is, what program was used to open changelog txt? So let's see if this exists in our output here. So okay, it doesn't tell us where it was, and now I need to find the individual file that was ran. So it's going to be the one that is at 6:35 a.m. All right, here is the file, and we need to expand some of these things. I wonder if I do multiple selections, I could probably expand multiple ones. Can I or no? Okay, so our control is the one that I hope. Okay, there we go. Now we can expand multiple of these, and let's see if we could do that. Column width, we'll do what, 20? Okay, there we go. And we need source file. That's definitely not the information. Yeah, it's not the source file information. It is something else. So it's asking for what program was used to open up changelog txt. So we need to see what we, okay, it's under path. I could have also just done Control F to find it on this, on all this information in here. So there it is, changelog.txt. It was Notepad. Of course it was. So let's see, is it going to show us the specific, it's, I mean, notepad.exe, I'm sure is the name of the file that was used to access it. So where is it again? It is this thing. So it's on row number 6. So take it all the way down here. And the local path, volume, access modified. It's notepad. Okay, I don't need to find it like that. I could just do notepad.exe, and I know that that's the answer. Okay, so there we go. We now found all of the answers in this particular situation. Now moving on to file and folder knowledge. All right, shortcut files. They exist in these specific directories, and so when Windows creates a shortcut for each file opened either locally or remotely, the shortcut file contains information about first and last open times of the file and the path of the open file, along with some other data. And we can find that there, and it'll be using the same lecmd executable, and that's going to be the path instead of the directory. I guess we're going to use the file. Then we have Internet Explorer / Microsoft Edge, which is a browser, and we can get browsing history from their web cache. And file folders access appears with a file yada yada asterisk in the Edge history. Though several tools can be used to analyze the web cache, you can use Autopsy to do so. So for doing that, we are going to do logical files instead of a disk image or VM file. And then we're going to add it from the triage C, and then we're going to do recent activity as the specific option, right? Yeah. So we're going to do C and recent activity, and then you'll be able to view local files accessed in the web history option in the left panel. So it'll be under data artifacts, web history, and then this is what it's going to look like. And from here, we can try to pull some details from it. And then jump lists, as we already learned, jump lists create a list of last open files. This information can be used to identify both last executed programs and the last open files in a system. Remembering from the last task, jump lists are present in the following location: automatic destinations. That was the most recent thing that we did. And we've learned about parsing jump lists in the previous task, so we don't go over that again. Let's analyze the triage data available on the following location in the attached VM. So when was the last folder Red Ripper last opened, and when was the above mentioned folder first opened? And I wonder if this is going to be a autopsy thing. No, it seems to be JLEC will give you the date time info. Okay, so since we're going to be using JLEC, I think is for jump lists, right? So yeah, jump lists. JLEC would be jump list. Windows 10, jump list is JLEC. So we're going to go over there, and we're going to run JLEC one more time against our automatic destinations, which I think it's all. Oh, I closed it, but I do already have the. Or did I delete it? I did delete them. So I need to now open up the recycle bin and take out the most recent file, which was deleted at such and such time, which is automatic destinations. So I'm going to restore this, and this is where it was. So we're going to open that back up, and that should have actually the information that we're looking for. I don't think I need to rerun any of this stuff right here, because we're not talking about anything that has to do with the web cache. They just want to know when the last time Reg Ripper was opened and when was it first opened. So the last opened and the first opened, and the hint says JLEC MD will give you the date and time info, and that's for both of them. So we're going to wait for this thing to open up, and then we'll run it. And here it is. So it's going to be on row 18 here. And so source created, source modified, source accessed. I think that would be the last accessed. And then creation time last modified, which would probably be the last time that it was accessed. Let's see if we can have any other. We have target created, target modified, target accessed. Okay, so it's the last modified right here. So it has nothing to do with the target created modified area. So it's the specific piece right here. So the last modified and creation time are probably what we're looking for here. And so in this case, we're doing Reg Ripper, which is this thing right here. So this will probably be the creation time, which will be the first opened. Yeah, there you go. Okay, so there you go. So we're looking at these specific two columns right here, the last modified and creation time for our automatic destinations, and I'll kind of zoom in for you. I mean, you can look for it yourself, but it's creation time and last modified are the ones that will give you the info that you need. And we are almost done with this, so we're now going to go into the external devices and USB device forensics. All right, set up API development logs for USB drives. When any new device is attached to a system, information related to the setup is stored in setup API devlog. It's present in this location, Windows, INF, setup, yada, yada, yada. And it contains the device serial number and the last times when the device was connected. So updated device right here. And then we have all of the information that is kind of included here. Then we have shortcut files, which in the previous task, shortcut files are created automatically by Windows for files open locally or remotely. These shortcut files can sometimes provide us with information about connected USB devices. It can provide us with information about the volume name, type, serial number, and so on and so forth. So recalling from the previous task, it can be found at the Windows and Office recent locations. under app data roaming. So as we have already learned, using LECMD, we're not going to go over it again. So what artifact will tell us the first and last connection times of a removable device? And this is actually right here, so we don't even need to do any extra work for this particular one. That's going to be our answer, and right there. And we are now done with this particular task, and we can move on to the conclusion and further material, which doesn't seem to be much here. It just says it wraps up the Windows Forensics 2 room, and it's been fun learning about it. If you haven't already, check out Windows Forensics 1, which is actually a free room. And then we're going to go into the CAPE room in a little bit because it's a part of the path that we're on. So congratulations, we finished this room. I hope you did the exercises with me, so I hope you actually got these things together and got them done. Got them done, get them done. If you found this information useful, or if you learned anything from this video, or if you want to learn more things about this pathway of digital forensics, go ahead and like, subscribe, and turn on the notification bell, and even drop a comment. All of those things do two things. One of them is that it actually helps us with the YouTube algorithm so we can get expansion of this channel and help more people just like you who are on this very same path of cybersecurity and pen testing, ethical hacking, all that stuff. But the more important thing is that when you turn on the notification bell, you get notified the next time a video comes out. And if you're studying to become a cybersecurity analyst or a forensic scientist or any of those great things, and ethical hacker, pen tester, all of these things actually apply to you directly. And not only will you get information that you can use on your examination to help you pass your exams quicker and easier, you can also use all this information in your work when you get into the industry. So it's a win-win situation in my humble opinion. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Hope you learned a lot from this room. Peace, love, and chicken grease, and I will see you in the next video. Later.